Hey everyone, thank you all for joining today. I'm Corrine Wallach. I am the community manager at StarTree. We have a very special presentation for you guys today. The presentation is on analyzing real-time order deliveries using CDC with Debezium and Apache Pinot. And our two amazing presenters are Gunnar Morling and Kenny Bastani. Thanks guys for joining.
Thank you, Corrine.
Thanks for having us.
So I'm going to let you guys do your own intros, but just for all the attendees, just a really quick lay of the land thing. If you have any questions, feel free to ask them in the Q&A. We will be doing a Q&A after both presentations, after the full presentation. We'll be doing the Q&A live. If you are watching this on demand afterwards, or you have questions after the presentation is over and the Q&A has ended, feel free to either jump into the Apache Pinot Slack. Kenny is pretty active there, so you can find him there. I just put the URL in the chat. Or you can also tweet at either Gunnar Morling or at Kenny Bastani. Their names are their Twitter handles, so it's pretty easy. I would suggest a tweet at them just because it would be fun. And even if you like the presentation, please give it a thumbs up on YouTube. Or you could also just tell Gunnar and Kenny directly on Twitter how much you loved it or what you loved about it.
Or if it sucked, right? You also can tell us if it sucked.
You can also tell them if it sucked. Yes, maybe in a nice way or not in a nice way, whatever your best way of saying that.
It's the internet.
We can take
anything goes.
It's the internet, so everything goes. I like that, Kenny. All right, so without further ado, I'll let you guys take it over, okay?
Thanks, Corinne. So welcome if you're joining along live with us today. I really appreciate it. I think we put these out recorded afterwards. So if you're joining live and spending your time with us today, really appreciate you. So the name of the presentation is Analyzing Real-Time Order Deliveries Using CDC. That CDC is we're not affiliated with the Centers of Disease Control. I know how that could get kind of confusing in this day and age, but it means change data capture. So Gunnar's going to go more into that. It's very exciting to be able to bring this presentation to you today after several months of getting together a microservice an open source example that bridges OLTP and OLAP. A little bit about myself. I'm Kenny Bastani. I'm an engineer and developer advocate at StarTree. StarTree is a startup that focuses on delivering a cloud platform for you to run Pinot in the best way possible. There is a lot of info on that. We just came out of stealth a couple weeks ago and had a product launch event. If you go to startree.ai, you'll get everything that you need to know about our platform, as well as we recently had a one-day virtual conference with a bunch of videos of our founder, Kishore, talking about the product, as well as people from around the community also weighing in. So I highly recommend going to startree.ai. So I've been doing software stuff for about 20 years. Before coming to Pinot about a year and a half ago, I was part of the Spring team at Pivotal, which is now VMware Tanzu. Wrote a book called Cloud Native Java, which is all about building cloud native applications with Spring Boot, Spring Cloud, and Cloud Foundry. The other publication to my name is 2 pages in the 97 Things Every Java Programmer Should Know. You should definitely buy that book. It's a great book. It has basically 97 of the biggest names or faces or experienced people in the Java community weighing in on some patterns. I talk about microservices and trade-offs. And that's about it for me. I'll go ahead and pass it to Gunnar.
Hey there. So, wow, that's really tough going after you with all these accomplishments. Hey, people, I'm Gunnar. I work as a software engineer at Red Hat, and I'm the lead of the Debezium project, which is an open source platform for change data capture. So, by the way, I have to mention that CDC, another thing it does not stand for in this context, is the Caribbean Developers Conference. Yeah. So I really like that. At one point, I would like to talk about CDC and CDC. You get it. Right, so I've been doing a few things and working on Debezium, Quarkus, which is a stack for building cloud-native microservices. And just a minute before we started, Kenny was so nice to put up this little book there, 97 Things Every Data Engineer Should Know, because I just recently had the pleasure to contribute one chapter about CDC to that book. And if you would like to know what I'm up to, new things I'm doing, then I would suggest you follow me on Twitter. And with that, Kenny, take it away.
Cool, thank you, Gunnar. All right, so I'd like to start with an icebreaker here. So the format of this presentation is I'm going to go ahead and go first here for the first 30 minutes and then pass it to Gunnar for the next 30 minutes, and then we'll take questions. But to start it out, let's start it out with an icebreaker here about databases, some database-related humor. So the joke I'm going to tell without any of you being able to hear any of you laugh, which on stage would be something that tells me that the joke landed. But I'm going to go ahead and try it anyways. So why did the OLTP database have trouble ingesting data? Anyone? Well.
Is this where I'm supposed to fake laughing?
Yes.
Awesome.
It had acid indigestion. And
I like
just in case Gunnar didn't laugh, I have my little laughing guy here. And just in case those following along at home did not get the joke, it stands for atomicity, consistency, isolation, and durability, which basically sets all of the trade-offs that we have for every single different kind of database that we use today. So acid indigestion is pretty funny. Okay. So I want to start out now talking about open source database adoption in the last 10 years because things have changed. So back in 2011, about a decade ago, it was around the time I started using a database, a NoSQL database called Neo4j. And I went on to work for Neo4j in 2013 as a developer advocate. And so in the last 10 years, I've followed closely with open source database adoption in that space, as well as being a big part of my career. So in 2011, open source database adoption really kind of looked like this. Of course, MongoDB was the first of the NoSQL databases to come along and really take people down a different road as far as moving them from relational databases to NoSQL. So this is the developer advocate on the street of Hacker News with the MongoDB article. And of course, we had in 2011 our full stack developer who was like, take my money, please give me that MongoDB. And that was pretty much how developer advocacy worked, or marketing databases, NoSQL databases. And so this started the revolution. Things have changed over 10 years. And so in 2021, things kind of look more like this. Where we have that same developer from 2011. He's moved to Antarctica and he's created a cloud platform startup for selling ice cubes on Kubernetes. And this is the real-time OLAP data store. This could be any data store today. There's as many open source databases today as there are front-end JavaScript frameworks, I'd like to think. And so what this really represents is that even though there are some amazing technologies that have matured, open source technologies, and specifically Apache Pinot, which we're going to talk about in a little bit, which was built at LinkedIn and is used by some of the biggest software companies in the world today, including Uber. And this really represents this fatigue from developers who really aren't looking at everything today that's out there because there's so many things out there. But Apache Pinot is one of those things that is really worth looking into. And so I had to come up with a different idea since I can't go on to the street of Hacker News and sell Apache Pinot to people. I had to do something a little bit different. So I decided to build an example. Because if you build an open source example, of course, developers will come. And there's more to that. I'm an engineer, I'm not a marketer. So I do developer advocacy, but I also have spent a lot of time in code. I spend time in code every single day, which is one of the privileges that I have in my role. Getting to write the 600 pages of cloud native Java, it was very technical. And so I'm lucky enough to be able to build open source examples. I call them highly available hello world applications. Yes. And so I decided to build one here for Apache Pinot plus Debezium. And what kind of example? Of course, order delivery. And why is that? Well, it is the era of the pandemic. And when I started working with Apache Pinot was right around the time the pandemic and lockdown started. And I was ordering Uber Eats like every day. I still order it maybe once a week. I try to cook more, but I was very inspired by being able to order food on Uber Eats, which is a real-time delivery service for food using the Uber's platform. because Uber, a lot of the stuff that Uber Eats provides you with as a service is powered by Apache Pinot. So a lot of the analytics behind what's going on there in Uber Eats is done using Apache Pinot. And now getting to learn more about why Apache Pinot is used at companies like Uber, at LinkedIn, Stripe, WePay, and not widely used by every other company in the world so far was interesting to me. And so as the adoption for Apache Pinot increases, there's definitely this signal there that tells you that it's really for the kind of real-time analytics that you need for use cases like Uber. So I built a real-time delivery tracking microservice architecture. So this is an open source microservice example. And it focuses on a lot of things. So if I had maybe 3 hours, I would like go through all of it, but I only have like 20 more minutes here to talk about it. So we're going to focus really on what we can, but I highly recommend heading over to the open source GitHub repository, which we will link in the chat. As soon as I pass it over back to Gunnar, I will link this in the chat. But you can get all of the details here on GitHub, and it walks through what we're talking about here with event sourcing, event stream processing, change data capture, and stuff like that. It also walks through the initial requirements, which I'm going to go over now. So I wanted to build a service that tracks new order deliveries. I wanted to get a load simulator that realistically simulates a fleet of drivers delivering restaurant orders to customers. I used a list of Starbucks restaurants as locations. So there's well over, I think, 10,000 worldwide, but I've limited it today to San Francisco because if I were to run the simulation at a worldwide scale, it would surely burn down my laptop. And it generates realistic delivery scenarios and simulates supply demands using pre-seeded variables. So this is kind of like almost like a game engine on top of a real back-end architecture that is simulating these orders. So the directions here to build and run are available. I suggest running it in light mode, which is what we're going to show you today. And so let's get back to the slides. If my screen goes dark, Gunnar, just let me know. It's happened earlier.
Looking good.
Okay, cool. All right, so change data capture is what Gunnar's going to be talking about later. Why we're talking about change data capture is there's a really interesting pattern with microservices, especially event-driven microservices, being able to use change data capture as a log of what's really changed inside your domain. So if I have a driver domain aggregate or an order domain aggregate, all I have to do for my microservice, instead of having a Kafka producer, is just update the aggregate itself, which generates an event in an event table. So we have an event table per aggregate. And those events then are picked up by Debezium's connector, and it is and put into a Kafka topic, which then I will ingest from Apache Pinot and be able to query it from the application itself. So I'm going to do a quick delivery demo from the dashboard perspective. So Kepler GL is a very, started at Uber, and it's open source today. And this is the demo. So if you go to Kepler GL, they provide you a demo, which allows you to load in a CSV file. I have one that I've already exported from Pinot. And here you'll be able to see that data that I've exported from Pinot. And I'm going to go ahead and animate it, which shows you the drivers. So these are the actual drivers and their routes over a period of something like 30 minutes. And I sped it up so that I'd like to think that they're driving a Tesla Plaid Plus edition with SpaceX rocket boosters, because it would be really boring to watch this not in real time like this. So here's our drivers going around from going to pick up their orders from a location and then delivering it. There's 50 or so drivers here, something like 100 or something restaurant locations. I think there's 50 restaurants locations. So I can go ahead and also add in the restaurant locations here. Oops. If by adding another data layer. And I think that's this one. And so those green dots are going to be the restaurant locations. And if I slow this down a bit, let's try 0.4. And let's go ahead and change this to be a heat map, as well as this. So now you can see when I zoom in here that these drivers are going to and from these different restaurant locations. Later on, I'm going to show you from the perspective of a single driver because it's kind of tough to see. But this is the basic idea of what I wanted to create. And this is that kind of real-time dashboard that gives you a view into what's happening in a certain area or just an area around the world that you want to zoom into using Apache Pinot. And then being able to see the behavior. Now, each one of these dots that you're seeing is actually an event that was generated by Debezium, exported to Apache Kafka, and then ingested to Apache Pinot. So we're actually looking at things at the event level. This animation wasn't, created using anything other than the raw data that was really captured by change data capture. So that's a very cool thing to be able to see. So I'm going to jump back to slides here.
Really cool. I got to say, it looks amazing.
Yeah. I was impressed when I put it in there. They're just events, and I didn't intend to see it like that. So what I'm going to do here now is I'm going to explore the microservice architecture to give you kind of a view into all of the containers that have application components in running. And then I'm going to show you a demo of Apache Pinot. I'm going to show you how these real-time tables were created, as well as the schema configuration and the table configuration. And then I'm going to hand it off to Gunnar to do the Debezium demo, as well as he has slides as well that show you the architecture.
No jokes.
No jokes. Okay, so this is what the microservice architecture looks like for the most part. Now there's more containers here, but this is kind of a good view of what it looks like from a high level. And so here we have the order delivery service. So this is the REST API that has a driver API and an order API. So primarily right now we have two parts of domain. That's the driver, and we have an order. For an order, we have each restaurant's going to have an order generated every 30 or 35 seconds or so, and it's going to go through a variety of state transitions up until the order being ready for pickup. And when that order is ready for pickup, we have drivers that are just driving around the location nearby, maybe a restaurant, and on their application on their phone, they might get a notification that says new order request nearby. And so I had to simulate this. Now, to be able to do that, I needed to be able to do a geospatial query that would look for nearby orders. And that's not something that I could do easily with an OLTP database or a relational database like MySQL. And so what I needed was something like Apache Pinot, which can go ahead and do geospatial indexing with an indexing technology from Uber called H3. So a lot of this stuff really came from Uber, and Uber actually being one of the committers to Apache Pinot was able to bring back in some of the technology that they use for their application as features for Apache Pinot in our open source project, H3 geospatial indexing being one of those things, as well as upserts. And so for the order delivery service itself, we have kind of this true CQRS pattern, which is that we have a query side and we have a command side or write side. So I'm separating my writes and reads. I'm writing to my MySQL order database here over JDBC, and those events are being exported using Kafka Connect Debezium from MySQL, which will go ahead and consume the log of these changes and push them into two different Apache Kafka topics. We have one for driver and we have one for order. And those get consumed by Apache Pinot, which does some transformation, does some aggregation, it does some indexing as they're coming in real time, making those records then, those events, are able to be queried from the order delivery service. So here's my read side and my write side here. I do have, this is a cloud native application architecture. So I do have Netflix Eureka as my discovery service, and my load simulator here, which is sending HTTP requests to the order delivery service. And we'll look at Eureka here in a little bit to see more about that. I also have an API gateway slapped on top of it because this could look pretty scary from an architecture perspective for a single microservice. But we have an API gateway on top of all of this, which exposes the order API and the driver API from the order delivery service. So everything looks quite nice. Now let's talk more about Apache Pinot. I'm going to show you some more stuff first before getting into Apache Pinot with cloud native architecture. So if I go to, I think I have Eureka up here somewhere. No. So, oops. You can still see my screen, Gunnar, right?
Yeah, all good.
Okay. So here's Spring Eureka. So this is originally Netflix Eureka. This is the discovery service that Netflix originally created and still uses today. And you can see that I have my order delivery service connected to it, as well as my API gateway, and it connects to itself as well. For my API gateway,
maybe you can make that a bit bigger. It's a bit small.
Oh yeah. So for my API gateway, we can go ahead and see the routes. So if I go to actuator gateway routes, we can see all the routes through the API gateway. So true cloud native architecture. I can go ahead and scale up my order delivery instances depending on the amount of demand that it's getting in terms of HTTP requests. And so more of that is available in documentation on the GitHub repository if you're interested in that. So back to Pinot. Okay, so let's talk about Apache Pinot. So what is Apache Pinot? I don't have a lot of time today to do a full introduction to it. The great thing is that we have tons of intro content available through our website. And I think Corinne will paste in some resources there. So tons of great intro content. So I'm just going to quickly tell you what it is. So Apache Pinot is a distributed real-time OLAP data store. So it's purpose-built to provide ultra-low latency analytics, even at extremely high throughput. It can ingest directly from streaming data sources, such as Apache Kafka, which is what we're doing in this example, as well as Amazon Kinesis. And it makes the events available for querying instantly or near instantly. It also can ingest from batch data sources. So it does batch offline data sources as well from Hadoop HDFS, Amazon S3, Azure ADLS, and Google Cloud Storage, as well as CSV files from wherever you want. So that's the high level. And I won't jump too much into the architecture, but it is a distributed data store. So there are distributed components here that we're running. So there's a controller, there's servers, as well as brokers. And again, this is all available in our documentation. But I did want to talk about a little bit about the architecture. It relies on Zookeeper. We have Apache Kafka in there as a streaming data source as well. All right, so let's go ahead and look at Apache Pinot, do a quick demo. So I'm going to go ahead and pull up a new window here. Okay, so this is the cluster manager UI. So when you start Apache Pinot up, at localhost 9000, we have our cluster manager UI, and this is going to give you a high-level view of what's going on in your cluster. Now we have tenants, controllers, brokers, and servers, right? So we talked about earlier the distributed components, our controllers, our brokers, which we query through, and our servers, which are segmenting the data that's being ingested. So our controllers are going to be our main interface to communicate with Pinot, and then our brokers are going to be the way that we query, and our servers are really going to be doing the heavy lifting in terms of returning back the results through query execution that's managed by the brokers. Now I have two tables in here. I have one for drivers and one for orders. And I'm just going to take a look here at the schema configuration. Let's go ahead and start with orders. Now, the first thing you want to do when you create a table in Apache Pinot is to create a schema. Now, you all know what schemas are. There's not much more in our configuration file than that, but we're going to go ahead and look at the order schema. So you can see the table schema columns here. Basically, you have an account ID, the status that the order is in, so it can transition from order created to order assigned to a restaurant, all the way to order delivered. Now, when the restaurant is ready for pickup, so when an order is ready for pickup, it'll go to the status will go to order ready for pickup, and then the driver API takes over, and the driver will then go and pick up that order, and then they drive the state of that order all the way to delivered. We also have an order location with our Latin longitude here, as well as the restaurant information on the order itself. So that's just for the analytics. So this is the event that really gets exported. I also have two fields here for the H3 indexing. So these are used for geospatial queries. And those essentially get transformed from, so we have a transform function here that's going to go ahead and transform the order location as well as the restaurant location. Now I have a primary key column here, order ID, since we have something called upsert enabled. And so upsert's essentially going to give me the illusion that I'm updating a particular record in a table in Pinot. But really what it does is it allows you to have two views of your individual records. One is a log of all of the events that have ever been ingested. And then the other one is the most current event that's been ingested. So this gives you the ability to view a replicated part of your domain from MySQL. Let's say it's the order aggregate or the order table, and you can just see the current state. But if you disabled upsert, you can see a log. So I'm going to show you that in a little bit. Now, the next thing that you need to do is to create your table configuration. So in the table configuration, I'm going to inherit my schema. So you can see that I have my table schema assigned to it here, and the schema name order. And here's the connection that I have for Apache Kafka. Now, this is the same Apache Kafka cluster that is being used by Debezium when it's exporting its change events to topics. So here I'm specifying that I want to ingest from debezium.order. So Gunnar is going to look more into that in a little bit. And that's pretty much it. There's a lot of other configurations here. This is for the H3 indexing. So right, we're doing geospatial indexing on all of those coordinates, those geo coordinates that are part of the driver API and the order API. And I specify here that I want to enable upsert as full. Also, I have some transformation configurations here. This is basically just taking a JSON map that is coming in through the message from the order topic and just turning them into actual columns so I can do some indexing on them. And that's pretty much it. So now let's go ahead and take a look at some queries that we can run on this. So if I go to my query console here, we can see some information get returned back from orders. But I have some pre-selected queries here that I wanted to show you. And we'll start out with the driver. So as these events from a driver are getting exported from Debezium to Apache Kafka and then ingested into Apache Pinot, I can go ahead and run a query here to get information related to an individual driver. So we looked at the driver events earlier in Kepler, the visualization tool. So here I want to go ahead and just see for an individual driver. So I'm going to go ahead and get driver with ID number 76 and his geospatial updates as well as the last modified time. And we get back, there's 1,387 events. So we have 1,387 frames of information from this driver that we can go ahead and visualize. And I'll go ahead and export this to CSV. And I can go ahead and open up a new Kepler GL demo. And I can load that data in here, and this is going to give me all of the geospatial updates for this particular driver. Now I can go ahead and animate this by selecting a start time here on a filter and go ahead and hit play. And we can see this driver as he's going about his day delivering orders. I can also add in another dimension here, which will show the restaurant locations. And so you can see him popping around the different restaurants. So the nearby, he's looking for nearby order requests that are available. So this is why he's kind of traveling in this vicinity and not kind of going outside the boundaries. Sometimes he does go out there because I think all of the orders are there's no orders in this particular location available. And so that's pretty much it for the visualization. So since I'm about out of time here, let's see, lessons learned, right? So as I built this microservice architecture, I really started with those initial requirements. And I started out using Apache Kafka as a producer from my application. And as a part of that, I ran into some issues with implementing upserts. Now, upsert, earlier we talked about, was the ability to kind of see a log of events versus a current state of a record. So if I disable upsert here, I'm only going to get back one result. So you can see here the one result. This is the most recent event that was ingested for this driver. And if I disable it, I can see a log of all events. So this is really useful to be able to see that history of events, especially for event sourcing. So some of the lessons learned was that after talking to Gunnar, I can completely replace my Kafka producer inside my application, which eliminated a lot of overhead, a lot of code. When you have a large microservice architecture with a lot of different teams and you have a lot of messaging going back and forth between these applications, which is pretty common, the Kafka producer can be a limitation in the long term for developers having to first learn to be experts at Kafka, which is not a bad thing to be, but unfortunately sometimes you hire developers that don't have that expertise, and them having to implement a Kafka producer in a microservice, they might implement it a different way than other microservice developers do on other teams. And so there's a lot to be worried about there. So just replacing that entirely with Debezium CDC was a wonderful thing to be able to do. This allowed me to really get to see the event table outbox pattern working for the first time, which was an amazing insight thanks to Gunnar's very quick implementation. It didn't take long either. It took me more time to remove the Kafka producer than it took to implement the CDC.
You don't know how long it took me to build it on my side.
Yeah, that's right. So this gave me some insights as well as to the nature of how we should develop our microservice architectures. I don't think there's really a need to have a microservice ever be a Kafka producer. And I could be wrong there, but I thought about this quite a bit. So microservices really just become consumers, right? And that makes sense from the perspective of the REST API, right? Because REST API, what do? We provide a REST API for other applications to consume from. And so we really are just a consumer on the microservice side, which is really interesting insight. So it doesn't have to be a Kafka producer. And also the ability to have this real-time OLTP to OLAP replication, and then being able to make reads back from Apache Pinot, that was very natural for me to have that ability to do these geospatial analytical queries directly on Pinot, and not have to worry about doing anything with my MySQL database itself for geospatial. So that was great. And so with that, I'm going to hand it over to Gunnar. And he's already introduced himself, but I put this at the end for the transition. Take it away, Gunnar.
All right, so people should see my screen. Let me go to the right one. All right, so let me arrange some things here just to bring my second screen in order. All right, Kay, thank you so much. This was really an amazing presentation. I mean, it was the first time I've fully seen it, right? And I'm really impressed what you put together. So that's really cool.
Thank you. Thank you.
And I mean, I like this point you made, right? So Kafka, of course, still is part of the overall solution, right? And we benefit from its scalability, its reliability, and so on. But then the developers of the microservices, those producing microservices, they don't have to think about this producer complexity, right? So I feel that's a good trade-off. And now, well, so we have seen all these amazing things we can do with Pinot and Kepler. And of course, we should also now answer this question: how do we actually get our data from the operational database over into Pinot, and so we can do all those nice things over there, right? And this is where Debezium comes into the picture. And I would like to explain it a little bit to you, what it does, how it works, and then I also will, show it a little bit in the demo how you would go about implementing that. All right, so let's get started. Well, what is it? In a nutshell, it is a very basic principle. You could say it's like the observer pattern for your database. So whenever there's a change in your database, something gets created, something gets updated, or something gets deleted, Debezium will react to this change and will capture it from the database, and it will send it to consumers. Now, you might wonder, how does it compare to other approaches? Maybe you have been using batch-driven approaches in the past, or some polling-based approach in the past, where essentially you have some process which goes to your database every now and then, maybe every minute, every hour, every day, gets the data from the database and sends it to some downstream system like Pinot. But really, well, there you have lots of latency, right? And you cannot really increase this interval so often. You cannot poll on a database every second. It would drive your DBA probably crazy. And this is where this log-based change data capture approach comes into the picture. So the transaction log in a database, it's the canonical source of the changes. So whenever a transaction gets executed in a database, the database will append entries to its transaction log. And Debezium goes to the transaction log and extracts the changes from there. So this means we can get all the changes in the right order. We also can get deletes, for instance, and we can capture them and we can send them to downstream consumers. You can use Debezium in different ways. Most of the times, people use it with Apache Kafka. If you have been using Kafka, there's a part of the Kafka project which is called Kafka Connect, which essentially is a runtime and a framework for building connectors, which either take data into Kafka, so that would be source connectors like Debezium, or sync connectors, which take data out of Kafka and send them to some external system. But then there's other ways you can use Debezium. There's a standalone mode, which we call Debezium Server. You can use it as a library in your Java application and things like that. To tell a little bit more about it, so there's this log-based change data capture implementation, of course. So that's the main thing why people are using Debezium, but there's more to mention about it. So for instance, if you don't have the transaction logs, let's say from 1 year ago, and you set up Debezium now, you would like to start with what's called a snapshot. So we take essentially the current data, we scan the tables you're interested in, and we send essentially insert events for all the existing data, and then it would go over to the log reading mode. So you have the snapshotting option. You have things like transaction markers. So people often are interested in transaction boundaries. So they would like to know what changes in my database are originating from one particular transaction. And there's support in Debezium, which allows you to essentially aggregate those events originating from one transaction and, for instance, emit them as a single event if you wanted to. It's all open source. It's all Apache licensed, so you can use it in any way you want. And there's a large community of users around it. So I believe by now it's more than 250 people who have contributed, but also there's a large community of users. So we are aware of, or I'm aware of, large production environments where people use Debezium to capture changes out of thousands of databases with tens of thousands of tables. It's used in companies like Shopify, WePay, Vimeo, and lots of others. So really, probably you are using Debezium without even knowing it, because really lots of big companies are using it behind the scenes. In terms of the connectors, so that's a little bit the challenge of this log-based approach. So there isn't one generic single API which we could implement and then have log-based change data capture for all databases. Instead, we need to have a bespoke, a dedicated connector for each particular database we want to support. So we have currently support for MySQL, Postgres, all the ones you can see here on the stable. There's a connector for MongoDB, for instance, Oracle. And we've also got a few ones which are currently in an incubating state, which are for Vitesse and Cassandra as two NoSQL databases. And very exciting for me, those two connectors, they are led by members from the community. So it's not even Red Hat engineers working on those connectors mainly, but it's driven by people from Bolt, in this case, or WePay, who are working on those connectors. So it's a very diverse community which has formed around it. And now why I find this exciting is, well, it enables lots of interesting use cases, right? So a while ago, I did this tweet. I hope you don't find it too cheesy if I put my own tweet here. But really, I think it's a large enabler, right? So it enables use cases like the ones we have seen today, or with the ones we are talking about today, and like replication in the widest sense. So taking data from a relational database over to Pinot, you could consider it's a use case of replication, but also it's a use case where we actually enable this sort of CQRS architecture, or where we enable to keep denormalized views of your data, so you can access your data in a very efficient way. But then there's more. You can use it to stream changes to your search index, or to update your cache. You might, for instance, think about having caches close to a user with denormalized views of your data. You can use it for syncing data between microservices, and there's tons of use cases more. And really, I would say it's a large enabler. So it's liberation for your data, right? So you have it there in your database. You don't have to go there and call for it, but instead your data comes to you if it changes. Isn't that nice? I really like that. Now, I would like to talk about one particular pattern which we often see being used together with Debezium, and that's called the Outbox pattern. And well, why are people using this? The question there is, well, people have different microservices, or in this case, maybe they would like to take data from one microservice as our order service over to Pinot. And now this data exchange, this should, of course, happen in a safe and consistent way, right? And typically, what it means is we need to do two things. So let's say this order service, it receives a new purchase order. Well, it needs to update its own database, but then it also would like to notify this other microservice. It would like to notify Pinot about this new purchase order. And those two things, updating the database and sending out this message, this needs to happen in a consistent way. So if either both things should happen or none of them should happen, right? What we don't want to have is updating our database, but then forgetting or failing to send this message to other consumers. So that's what we want to resolve. And this is where this Outbox pattern comes into the picture. Now, of course, if you think about change data capture, well, you could use CDC for implementing that, right? So you could just go to your database and capture the changes from the table, let's say, with the purchase orders. But now if you think about it, well, you would kind of expose your internal model. So if you do a change to the schema of this orders table, for instance, this would impact your downstream consumers. And now sometimes people find this concerning, other people are fine with that, but it's something to think about. And the Outbox pattern helps us to resolve this. So how does it work? The idea there is, well, you have your transaction, so your database, your service updates the database. And the idea is, well, if you cannot do two things at once, updating a database and sending a message via Kafka, for instance, to a consumer, you always can do a single thing consistently, right? And this is updating our database. So we can update our tables, let's say our orders table, our drivers table, and then within the same transaction, so this happens consistently and atomically, coming back to Kenny's asset joke, we also do an insert into another table, which is called the Outbox table. And the Outbox table, well, it's already in the name, really. It's an outbox from messages which we would like to send to other consumers. And now what we do is we use Debezium to capture the changes, and really it's only ever inserts, so you would never modify events. So we capture the inserts from this Outbox table, and we send those events over to our external consumers, be it other microservices, be it the search index, be it Pinot, or whatever. Now, this Outbox table, how would it be structured? The idea there is to base it a little bit on the ideas of domain-driven design, and this is how this table schema looks like here. So there you have things like an aggregate ID. So in case of our orders, well, the aggregate ID, that would be the ID of our purchase orders. And the idea is to use this aggregate ID as the message key in Kafka. If you have been using Kafka before, you will know that the ordering of messages is based on the message key. Now, what we would like to have is all the messages which pertain to one and the same purchase order 1, 2, 3, or which pertain to the same driver instance, they should be ordered correctly. And this is why we use this aggregate ID. So it would be the order ID, it would be the driver ID, and this is what we use as the message ID in Kafka. Then we have things like the aggregate type. So in our Outbox table, we would like to distinguish between events of different types, which we, for instance, can use to send those events out to different topics, and then consumers can just subscribe to the topics they're interested in. And lastly, there's this payload column, and this really is anything. In this case, it's a JSON structure, which is the message which we would like to send out to our consumers. And this JSON message, or this JSON structure, this is the contract, or it has the contract which we want to obey if we talk to our consumers. So here we would be very careful about evolving this contract. We wouldn't simply, change the types of fields and so on. So next step then would be to use consumers like Pinot to subscribe to those topics, and they would take the data and just ingest them into their own local data store. And now in our particular use case here, well, we would have this loop back to the auto service, and this is where this notion of CQRS comes into the picture. So the auto service would do read requests to Pinot, and it would use the querying capabilities which we have in Pinot and which we don't have in our relational database to set us or to implement those advanced use cases which we have seen. So this is how we bridge the OLTP system, in this case MySQL, with the OLAP system, Pinot, and we kind of blur the boundaries. And really, when I was working with Kenny on that, I found this idea that you bridge those boundaries between OLTP and OLAP. I find this very, very fascinating. So that's the Outbox pattern. And let me show you some of those things a little bit more in the actual code. And for that, I need to do, so I got the same demo running, which Kenny has running before. And the thing is, this takes lots of CPU, really. So there's this load simulator, which produces all the orders. And I didn't want to keep this running all the time because it just, it would blow up my laptop. So that's why I'm just starting this now. And in the meantime, I can talk a little bit about some other things while this is starting up. So what I want to show you is the configuration of the Debezium connectors. And for that, let me take a look there. This connector here, Debezium MySQL connector JSON. And if you have been using Kafka Connect before, this will look familiar with to you. So you specify your connectors in this JSON format. So you say, what connector? In this case, I would like to deploy an instance of the MySQL connector. What is the database? You can specify some filters, like you would like just to capture a subset of tables and columns, for instance. And you have things like a converter, which tells, okay, the message format for this particular message or topic, this should be JSON in this case. And now, usually I would use Kafka Connect and the REST API to deploy this. But what I'm doing instead is I'm using a new tool, which I've been working on just over the last week. And you're the first people to ever see this in a live demo. So I'm really excited. It's called KCCuttle. And KCCuttle is a command line client for interacting with Kafka Connect. And this makes it just a bit easier for working with Kafka Connect, deploying those things, and so on. And if you have been using kubectl before, then this will be pretty familiar with to you. So I'm doing KCCuttle apply. And why don't I have auto completion? That's already that. Oh, I do. So let me see. And I need to specify the file. Oh, I see. I got my screen a bit hidden. Okay, file. I need to specify this name now, which of the file I would like to deploy. And I also specify a name for this connector. And in this case, I just say MySQL CDC. And now this registers the connector with Kafka Connect. And I also can do KCCuttle get connectors. And then I see, okay, this is running. And I can also describe it. And I will see some more information. And I always get this nice cat completion here. So if you have been using the REST API, you will realize this, or I suppose you would see it's very easy to use. And now I see, okay, my connector is running. This is its configuration. Its tasks are running, and so on. Okay, so now this connector is running. And I should, the next thing I would like to do is I would like to take a look into this database. So let me use this tool, myCLI. And here I would like to select the data from this orders table. And I hope if I execute this again and again, yes, the IDs change. So you see new orders are coming in. So this load simulator is working. And you see it has the same columns which you just have seen on the slides, like event ID, aggregate type, payload, and so on. By the way, the event ID, that's a unique message ID which a consumer could use for deduplicating messages in case it would see duplicates. So everything here in Debezium and Kafka has at least once semantic. So this means in case of a failure, let's say Debezium or Kafka Connect crashes, it doesn't properly shut down. It could happen that it goes back a little bit further in time to read the transaction log from an earlier offset, and you would see some duplicates. And a consumer could use this unique message ID for deduplicating messages, provided it keeps track of the messages which it has received. So now let's take a look into the Kafka topic. So this is the data in MySQL. It's changing. I'm getting new purchase orders. And I take a look at this Kafka topic there. And for this, I'm using another nice tool called Kafka Cat. And I would like to take a look into this topic here. So let's see what we got there. And I'm piping the output to JQ, so it's nicely formatted. And Now let's talk just briefly about the Debezium change event format. So I have those blocks here, before and after. They describe the structure of my data. In this case, it's always insert events. That's why this before part is null. Where if this would be an update, we would see both before and after. Now in this case, I just have the after part, and I see the columns of my table. So they are the fields here, right? Event ID and so on, or the payload. And I got this source structure here. So this is some metadata which tells me what database is this, where is this coming from, which table, some timestamps, position in the log file, things like that. I see this is a create event, and I could get some transaction metadata here. So this is how a Debezium change event typically looks like. And now, in case of Pinot, well, we are only interested really in this particular payload here. So if you remember, we have this outbox table. So we don't want this before state. We don't even want all the things from this after state in our Pinot system. We just would like to have the information from the payload here. So, and now I guess I could implement this somehow in Pinot to extract this, but we also can do this in Debezium and Kafka Connect, and this is where the notion of message transformations comes in. So I can modify messages as I send them into Kafka or as I take them out of Kafka. And for that, I'm registering another connector using MySQL connector order Outbox. So let's take a look at that one. And you see it's, again, it's an instance of the MySQL connector. It's going to the same database, but then it captures the same table, this order event table. But then I do some transformations here. And essentially, this is a sequence of transformations which get executed. And let's just focus on this Outbox one. This is a message transformation, an SMT, a single message transformation, which comes with Debezium. And it essentially takes care of implementing those Outbox semantics files. So it takes essentially this payload of the message, so I can configure what column is my payload column. It's order payload in this case. It just will propagate that part. And it will do things like making sure we use the right message key. So I use the the aggregate ID. I use this as the event key. So I have the proper Kafka message key. And then, for instance, it does propagate this event ID. It propagates it to a header property in the Kafka message. So that's the Outbox event router. It comes with Debezium. And now I just have those other transformations here, essentially to work around some shortcoming, which is the following. So this Outbox, this payload, right now it would be a stringified JSON structure. So a single string field and which encodes a JSON structure. So for instance, the colons or the quotes, I should say, they would be escaped. And this is not what we want. Instead, we would like to have a JSON structure as the entire payload of the message. And just in a nutshell, those three SMTs, they make sure that I have this expansion of the single string into a proper JSON structure. And I don't go into details. It's not too exciting, but really, this is what this is about. So let's take a look at that. I should deploy this connector now. So use KC couple again. Let's say apply. And now in this case, I use this Debezium MySQL order Outbox connector. And I should name it order Outbox. And I'm going to deploy another one, which is for the drivers. So as I mean, usually I could have a single Outbox table, and it would have different messages of different kinds, different aggregate types, and they would be routed to different topics based on the value in this aggregate type column. In this case, the demo is implemented in the way that we have multiple Outbox tables, which works equally well. So I just deploy another connector. Actually, I could also have used the same connector, or maybe not, because the filter configuration would have been difficult. So I'm going to deploy this separate one. And I call this driver Outbox. And now, again, I can take a look at my connectors. They should all be running. And indeed, so that's looking good. So now I can take, again, a look into Kafka Cat, or into the Kafka topic, I should say. I'm going to copy this here. So here I'm taking a look into my order topic. And now I just should see this payload from my order message. I start this at the beginning. Let me do it from the end. Otherwise, we just have to reread the entire topic. I cannot do this. Let's take a look there. And now as this load simulator produces more orders, we see those events come in. And now you see the value of the messages. It's just this payload structure, right? And it would also be interesting to take a look at the key. So let me do this as the last thing, really. So I'm just executing Kafka cat again, and now I just format the output of Kafka cat a little bit different. I also show the contents of the key, of the message key, and I also show the message headers, so we can see that. I cannot pipe it now to JQ any longer, unfortunately, so it won't be colored, but we see the full messages. Let me stop it again. And what we see now here is I see this key, so that's the aggregate ID, like the order ID. And I have those headers here, or the single header in this case, and this is the event ID. And now a consumer could use this to deduplicate or to recognize events. And the Kafka message value, well, that's again this JSON structure as we've seen it before, and this is what we can use in Pinot. And I could show you the same thing for the driver topic, but really it's the same things. It's not too exciting. So let me just show you in the data in Pinot, so you can believe me, it actually works. I need to find the right window. There you go. And I have this query which Kenny gave me, so I'm just going to execute it. I hope it does the right thing. Let's see. It runs, and well, it fetches the orders here, right, with the pickup point and the status and so on. And now if you take a look at the number of docs here, this should increase as I execute this again and again, but you can see that. So now keep this running a few times. See more orders are coming in. And this is the nice thing now, right? So our data in the production database changes, in MySQL changes. Debezium picks it up with a very low latency. We have the data here in Pinot. And then again, our order service can come and can query Pinot and do queries which it couldn't do in MySQL. And this is what I tried to describe as tearing down the walls. Tear down the swamp, Mr. President. Or who was it? I don't know. Tearing down the walls between OLTP and OLAP, right? I think this is really exciting.
Mr. Gorbachev, tear down that OLTP.
Oh, yes, you know it. I should have practiced that one before.
Yeah.
All right. And actually, I believe that we got some more time, right? So I want to show one last thing, and this is how we can actually go about producing the events from our application. This is, Kenny made that point before, right? This Outbox pattern, it really allows us to, or frees us from having to think about producing Kafka messages, because in the end of the day, it's just inserts into this Outbox table in our database. And this makes it a bit easier for us. And now I could just implement this, and I could just use plain JDBC or something like Juke or Hibernate or whatever I like to use, and persist those events. What I'm showing here is from the Quarkus project. So that's a stack for implementing cloud-native microservices. Super interesting. And what it does, or one of the things it has is it has an extension for implementing the Outbox pattern with Debezium. And now the way this works is, so that's from a different example, I should say. I'm just showing it here to make one particular point. So here I use JPA for doing some change in my business model. So now this is named your event, but think about like order, purchase order, or driver, or whatever. And so I just do some change to my database. I persist this, and at the same time I use here the CDI event API to fire such an event. And for instance, in Spring, it could be Spring application events for emitting those events. And now there's an implementation backing this, which takes those events and which persists them in the Outbox table. Now you might wonder, why is this better than just persisting an event myself on our application code? And I would say there's some reasons for doing that. One of them is housekeeping of this Outbox table. So, well, if you only ever do inserts, at some point we would like to remove those events. And actually what this Quarkus extension does is it inserts the Outbox events, but then at the same time, at the same transaction even, it also removes those events. So what this means, when you query this Outbox table in your database, you would always see it as being empty. And still for Debezium and change capture, it's enough to pick up the change events from the transaction log. So we don't have to go to the table. We will just see it. We will get it from the transaction log. And that way, this table, it never grows. And this is, for instance, one nice side effect of having this sort of abstraction here instead of doing all this by myself. And I believe really this is what I wanted to show. Kenny, I would hand it back to you for some wrap-up.
Excellent. Thank you, Gunnar. I think that that's all we have for today. I think we're right on 59 minutes. So we have some time now to get some questions, if there are any questions from the audience. Usually, Corinne, yeah.
Hi, I'm back. Dude, this was amazing. This was so good.
Thank you. Yeah.
Thanks. That's great.
It was a really, really good presentation. Like, wow.
Awesome. Thanks. I'm so glad it worked, Kenny. I mean, it was so many moving parts, right?
Yeah. It all came together in the end.
Excellent.
Well, it does seem like people are grateful for you guys taking the time to put it all together and like working on building all this stuff. It definitely looks like a lot of work, but I have to say it was like one of the best presentations I've seen in a long time. So it was really good. You guys are a good duo together too.
Oh yeah, thanks. We should do it again, Kenny.
For sure, yeah.
So for the people watching, if anybody has any questions, there was a lot of questions that were kind of floating around, which we can kind of go through it. But if anybody has any questions that haven't been answered, please ask it again now, and just post it in the chat. There is like a 10 to 15 second delay sometimes, so it might take us a minute for the questions to start coming in. But yeah.
So I see one from KY. Maybe I can answer that. So KY Sheng, he's actually he's a member of the Debezium community. He was one of the main contributors working on the Vitesse connector. So hey, KY, nice to have you here. And he's asking, can the Outbox pattern replace stream processing with Flink, KSQL, or stream processing joins? And I would say yes, it can, right? Because let's say in the relational data model, we have this purchase order, and typically this would be spread across multiple tables, right? So maybe we would have a table with the order headers, and then we would have another table with the order lines or order line items, and the entire purchase order. This would be like a join of those two tables, right? Now, of course, you can do this join after the fact using Flink, using Kafka Streams or Spark, whatever. But it actually gets quite tricky if you want to do this. And well, if you do have control over this application and you can modify it so it produces the event into this Outbox table, then you don't have to do it, right? Because you already have this pre-join structure in the Outbox table, and you have, for instance, transactional consistency, and it definitely simplifies things. But then, of course, there's other cases where you would like to do this post, let's say, after the fact joining. For instance, if you cannot modify the source application, maybe it's a legacy application. Maybe you don't even have the source code. I had once a war in production. We didn't even have the source code any longer. So maybe you have this sort of situation, right? And then you would use this, stream processing just based on the different table streams.
That's a good answer, yeah. I guess I would add to that, there are probably going to be some examples where you might want to use Flink for doing some joins. But as far as the pattern that we see here and the implementation with the example application, I have not found a need to use Flink. Originally, we were going to have another presenter join us for this presentation, so we were going to have a third person. And it was going to show a data processing pipeline with Flink as well. And so there are some use cases that we identified for that in terms of doing some kind of aggregation for some analytics to do like sentiment analysis, stuff like that.
Or pulling data from another system, right? So let's say you have some sort of master data from another system, or IoT data which you would like to feed into this. Then Flink or Kafka Streams would be great, right?
Right. Yeah.
So we do have, we can go through these. I don't know if I don't see any new questions coming in, but there was a lot of activity in the chat. If you want, we can kind of run through it. I know Gunnar was answering a bunch of questions at the beginning, right?
Yes.
Do you have the ability to see these chats, Gunnar? Or
I see it here on StreamYard. Yeah. Not sure how it works, but I do see it. And
there's a lot of, it's just regular conversation. It's just one big stream.
So Kenny, there's one for you. Can Pinot ingest the schema from the Everest schema registry, or does it need to be manually created?
It needs to be manually created, yeah. And you'll want to manually create it as part of the schema itself and the schema configuration. You'll want to make some modifications to it. You'll likely have additional generated fields that you'll want to create for your real-time table. There's a lot of transformation that you can do at that level. And I would take a look at the source code or just kind of rewind this video later and look at the schema itself. And you'll see in there that I'm doing a UDF function to essentially do indexing, H3 indexing, geospatial indexing on the latitude and longitude, which converts it to a bytes field. So there's a lot going on in that schema configuration itself.
Mm-hmm.
We're also going to put on timestamps on the video, so people will be able to like jump around if they want to like see the live demos or whatever. Okay, so there are some new questions that just came in. I could read them out to you if you guys want.
Yeah, sure.
So Ali says, what criteria do you have while selecting single outbox pattern versus multiple outbox tables?
Oh, that's a good question. So to be honest, I think I always would go for a single one, really. And then, this Outbox event router, it has the ability to route Outbox events of different types. So let's say all those drivers, I don't know, whatever your domain is, to different topics. So consumers could subscribe to just those topics they're interested in. So I think I would go for a single table. But I don't know, in this case, Kenny went for multiple ones. It's equally fine. I think you have the choice.
Yes. So the reason why I decided to go with two different table outboxes was because I'm using, at the REST API level, I'm using hypermedia. So when you go to a hypermedia API location, such as order or a driver, you have a link to be able to see the log of events, which are domain specific to each one of those objects. So you'll have a domain event for driver and a domain event for your order itself. Yeah. And that was the reason why I kind of got locked into that.
And I was cheating a little bit actually in my part because I didn't show those domain specific columns from the Outbox table. I was skipping them. But yes, they were indeed specific to the type of the aggregate in this case. So yeah, that makes sense.
I'm just going to continue reading some of Ali's messages because it still talks about the same thing. So in Keynote, I have seen you assign multiple events into one single Outbox table, but in live demo, we preferred creating new Outbox table for each event. Can aggregating them into one Outbox table create bottlenecks like PK locking, etc.?
I don't think you would have to be concerned for that. So unless you have this notion where you would like to add some domain-specific columns, I would recommend go for a single Outbox table by default and take it from there.
Okay, Arvindan asked, could you talk about alternate solutions to Debezium in CDC space and how Debezium fares amongst them?
So that's, of course,
CDC.
People love these questions.
That's my favorite question, of course. Arvindan. So I'm familiar with Debezium. That's the project I work with. Of course, there's other options you could explore. But really, to make a meaningful comparison, it would have been you to do this because only you know your particular requirements. You know which databases you would like to use. What other non-functional requirements you might have. So really, you should take a look at the different options which exist, and you should make a decision based on your particular situation and context. I mean, whatever I would say, it would be biased, right? So I would recommend check it out for yourself.
It's good. It's a great answer. Saijin asked, how reliable the aggregations of Pinot in real time, especially if we have negative values as well?
It's getting tougher.
Yeah. So I'm not sure.
The questions are getting harder.
I'm not sure I understand the question fully with the negative values, but I can tell you that the aggregation in Pinot is very efficient, very fast. And a lot of that has to do with indexing. So being able to use the right indexes for your data is going to optimize Pinot's ability to select that from certain segments that are distributed across the different servers and being able to aggregate that more quickly. So the key idea here is that if you're scanning, you're spending less time scanning for the data that you want to aggregate on, the aggregations are much quicker. But it's pretty heavy duty in terms of being able to aggregate in real time.
Nice. I just posted for a final call for questions. There was so much conversation. It's like really tough to go through all this stuff. Let's see.
There's one from Nuratin. Does anyone have any experience with protocol buffers and Outbox Pattern? So I don't. I haven't seen that, but I have seen people who use Avro with the Outbox Pattern. So essentially, they just put an Avro blob into this payload column. So I would expect you can do this equally with protobuf or other binary formats. So I think it's something you can do if you are in the protobuf ecosystem, let's say.
The jokes were really great, by the way.
Oh, thank you. You will get your money for that later.
Let's see. So there was something else I saw in here that was like, okay. All right. So it looks like Gunnar, I'm going from the top. Looks like Gunnar answered a lot of these questions.
Somebody was asking about Java 16, Kenny, because I was tricking you into using Java 16.
That's right.
People confuse it because they didn't have 16 yet.
Yeah. So keep them on their toes. There was a question, do we have Apache Pinot as a completely managed service on cloud providers? I would check out startree.ai and see the managed service that we're providing with an early rollout to certain users. That would be a good place to start.
There's one from Kishore. How often does Debezium checkpoint, and where is the checkpoint saved? So that's a very good question. So in the terms of Kafka Connect, it's what we call the source offset. And this is stored in intervals. I believe you can configure this. I'm not even sure what's default, like every 30 seconds or something like that, but you can configure it. And then this is stored within a particular Kafka topic. So you even could use the Kafka consumer to take a look into this offsets topic, and you would see the source offsets of the different connectors. And of course, now, let's say it happens every 30 seconds. And now after 25 seconds, Debezium or Kafka Connect crashes. Well, then it would continue from this offset from 25 seconds ago, right? And this is where this idea of at least once semantics comes into play, because we don't commit offsets after each particular message. So after an unclean shutdown, you would have to be prepared to see some duplicated events.
Josh Ehrenberg had asked, this was like earlier in the session, said, can Pinot ingest the schema from Avro schema registry, or does it need to be manually created?
We already took that question.
Oh, okay, just kidding. Thank you.
No worries. Deduplication.
Yeah, right.
There's a lot of comments. There's a lot of conversation here. It's like kind of hard to go through it. Sometimes people answer them and like, yeah. So I think that might be it, unless anybody else has any other questions.
I think we'll go ahead and call it. We're available on Twitter 24/7. So
well, so I do. I don't know.
Gunnar does take breaks.
12:05.
Penny does not.
I have to create a load simulator for myself to be able to answer questions 24/7.
No, but also in seriousness, right? So people definitely, please feel free to reach out to us on Twitter. For Debezium, we also have a mailing list. I believe for Pinot, you have the Slack channel, right? So there's different places where you can find us, and we will be very happy to answer all the questions as good as we can.
This presentation was awesome. Thank you guys so much for taking the time.
Thank you.
Thanks for having us.
And then for all those who are watching, we have a meetup tomorrow as well. So it's operating Apache Pinot at Uber scale with one of the senior software engineers at Uber. So that should be a good one. So please join us for that. And also like, comment, subscribe, tweet at Gunnar and Kenny, give them good and bad feedback. And if you have it, whatever feedback you have, I love getting tweeted at. And thank you guys all for joining. Thank you guys very much.
Thank you so much.
Thank you. Take care.
Bye-bye.
Bye.
Bye.